Hi friends, welcome to my YouTube channel. Friends, in this video we will study the concept of Millman Theorem. So the statement of Millman Theorem is, according to this theorem, n number of Thevenin equivalents can be replaced by single Thevenin. So the statement of this theorem is, according to this theorem, n number of Thevenin equivalents can be replaced by a single Thevenin equivalent. Suppose this is a circuit, okay? So this circuit has n voltage sources connected with n resistances in series with it, okay? So this whole circuit can be represented by, here see, this is a Thevenin equivalent circuit, this is second Thevenin equivalent circuit, this is third, and this is nth, okay? Why it is Thevenin? Because it has voltage source connected in series with the resistance. So we can assume this circuit containing n number of Thevenin equivalents. So this circuit can be represented by a single Thevenin equivalent. Here voltage is Vm and resistance is Rm, okay? Now what is this Vm? Vm is equals to G1 into V1. Here G1 is the conductance. Conductance is inverse of resistance, okay? So G1 is equals to, G1 means 1 by R1. So G1 into V1. Here minus G2 into V2. Why minus? Because you can see that polarity is opposite here, okay? Here polarity is plus minus like this, and here polarity is opposite. That's why minus G2 V2. Again plus G3 V3 plus, similarly we can write up to Gn into Vn, and we divide this whole by G1 plus G2 plus Gn. So this is the value of Vm. Now what is the value of Rm? This Rm is equals to 1 by G1 plus G2 plus Gn. So in this way we can draw such n number of Thevenin equivalents into a single Thevenin equivalent circuit, where Vm is equals to G1 V1 minus G2 V2 plus G3 V3 plus Gn Vn, G1 G2 G3 Gn, and where Rm is equals to 1 upon G1 plus G2 plus dot 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 Gn. Here you have to be careful while choosing the polarity, because wherever you get opposite polarity you have to choose the negative sign. So this is all about the Millman theorem. Now I ask you a simple question. Suppose here in this circuit V1 is equals to 7 sin 60 and V2 is equals to 2 sin 3t, and suppose R1 is replaced by capacitance C, okay? This V1 is 7 sin 60, and suppose V2 is 2 sin 3t, and this resistance R is replaced by capacitance. Now can we apply Millman theorem for these values of voltage and capacitance? So here answer is, we cannot apply the Millman theorem here, because see, here this voltage source V1 has angular frequency 6 and this V2 has angular frequency 3, and we know that capacitive reactance depends upon the angular frequency, that is equals to minus J by omega C, okay? So here that frequency of V1 and V2 is different, That's why we cannot apply Millman theorem having voltage sources of different frequency and a frequency dependent parameter in the circuit. So, but here we can solve this circuit if such parameters are given by superposition theorem. So here superposition theorem is applicable, but Millman theorem is not applicable. So this is some more concept about this theorem. I hope you understand the video. Thank you. Jai Shri Ram.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.